Hi, my name is Dennis Pengizu. Our project is called Smart Stoplight. Our advisor is Professor Michael Caggiano. My teammates are Harmon Cayley, Nick Hahn, and Daniel Anderson. An introduction to our idea was to use computer vision to change the way traffic intersections are managed. In order to do this, we would create a device that would be easily attachable to a traffic light and avoid the current cost of installing induction coil directly into the pavement. Our proposed device is going to manage traffic by counting the cars in each lane, and if there is a necessity to advance with a turn signal, the device will switch to the appropriate light. Currently, we are looking to test out this device using one lane of traffic. If this proves to be successful, then we will seek to implement multiple lanes. Why is this an issue? Well, the current state of traffic management systems are rudimentary. They are expensive to install. The induction coils that are currently installed require infrastructure to be destroyed for their installation. They are also unable to adapt to different situations quick enough. Let me ask you this question. How many times have you found yourself alone, sitting at a traffic light, waiting patiently for it to change? This can be frustrating, especially when you're at a traffic light that you could be waiting 5 minutes, 6 minutes, 7 minutes just for it to change to green. Especially at nighttime when you're most likely the only car on the road going either left, right, or forward. There's been no effort to implement innovative traffic control devices since then. There's a tangible economic cost to idling traffic. The tools we're going to be using in this project will be OpenCV, Raspberry Pi, a camera module, infrared camera module, and infrared floodlight. The camera will be programmed to recognize objects and will send a video stream to the Raspberry Pi. OpenCV will process the video stream to highlight edges and contours of vehicles through manipulation of the frames from the video. This will enable us to count vehicles and write programmable logic that will conduct traffic accordingly on a stoplight.
So our initial course of action. So once we received our equipment, our first priority was to figure out how to set up a video stream from the camera module to the Raspberry Pi. Basically, the camera takes the footage of the cars in each lane of the intersection, and then it sends that to the Raspberry Pi. Once that data is sent to the Pi, we start our coding process. So summarizing our coding process a little bit, our input was basically the video stream from the camera. And then we did some research and applied this algorithm called background subtraction into our code. Briefly speaking, what background subtraction does is it basically isolates the objects from the video. Now, of course, the objects in this case would be the amount of cars in each lane of the intersection. Then the program will basically count the number of cars inside an enclosed area marked by a horizontal line, and then it will send a signal to output the color of the traffic light based on the amount of cars in each lane to direct the flow of traffic. Now, we were originally planning on using Python to code, but due to the difficulty of it, we ended up using C++. We'll explain the difficulty later, but in terms of the coding, we basically use C++ along with OpenCV. I also want to note that we didn't really finish the coding process due to the pandemic and the time constraint. We do have a lot done, but we just couldn't really finish it. But we are still in the process, and we are looking forward to finish it soon. And also, we want to demonstrate our project using a scale model with toy cars and a simulated intersection, but due to the pandemic, we didn't really have a chance to. And speaking of which, this pandemic was one of the difficulties that we encountered while working on this project. So now talking about the difficulties, the pandemic really didn't allow team members to meet up and work together in person because we had to practice social distancing. So with that being said, it was really hard for team members to share the hardware and to meet up and work on this project together and collectively as a whole. But we still try our best to an extent. We also had difficulties using OpenCV. This was basically everyone's first time using OpenCV. We had no prior experience. So we really had to take the time to learn it and get comfortable and get used to working with the libraries and everything. And because of the pandemic, some shipping of the parts that we ordered took a really long time to get here. So by the time that it got here, we didn't have enough time to properly test and implement some of the parts, such as the LED lights and the power supply unit. There was also difficulty with Python. We found out that the code processing the video took forever to do with Python. So that's why we switched to C++ instead, because upon research, we discovered that C++ processes videos a lot faster than Python. So again, due to the speed and efficiency, we made the decision to code with C++ instead. So what did we do to overcome some of these difficulties and complications? Well, due to the pandemic, we ended up doing a proof-like concept, which is to basically explain our project and how the traffic light logic would have worked if we would have completed the project. We had to get rid of the IR sensor and nighttime function for now, since it may require a different object recognition method compared to the daytime. And instead of doing a live demonstration of a scale intersection, we switched this process where we found existing online footages of intersections, and then we implemented our logic based on those footages by demonstrating the functionality using a virtual stoplight output. And since we switched to C++, we had to refreshen up our skills a little bit with that language and learn how to use OpenCV through C++. And even though we couldn't really meet in person, team members did have weekly meetings online through Zoom, where we basically logged on and just discuss our progress and how much we have gotten done and how to improve this project going on forward. So this was basically the idea of our project. We want to create a smart traffic light, if you would say, and its purpose is to direct the flow of traffic based on the amount of cars in each lane of the intersection. We obviously had difficulties as stated, but we try our best to overcome some of these difficulties and to do as best as we can to our abilities with this project. Now, our team member Daniel will talk about what we have actually gotten done and conclude how the implementation would have actually worked, along with some additional functionalities and features that we would have liked to add to our work.
The coronavirus has forced us to reevaluate our goals for this project. However, we still have been able to continue to work on our design to deliver proof that our concept can work. So far, we have been able to successfully establish a video feed from our camera module to the Raspberry Pi. Using a background subtraction method, we isolate the cars in each lane into an enclosed space. Our program counts the number of cars in each enclosed space and sends a signal to the traffic light depending on the scenario. We currently have highlighted 3 scenarios to test our design. For each scenario, we are testing only the left lane on one side of the intersection. In the first scenario, no car has been detected in the left lane, so the light will continue green. In the second scenario, a car has been detected in the left lane, and the program will begin a 1-minute timer to halt traffic on both sides of the intersection until there are no cars detected in the left lane. We then set the camera to not scan the lane for 2 minutes, allowing for main traffic to resume. This cycle will repeat once the 2 minutes are over. For the final scenario, if the light has been on for 3 minutes, it will switch to yellow, then to a red light on a 5-second sleep timer between transitions. We believe that this idea can be implemented and expounded upon. Using this device in place of the current system will expedite traffic while saving money on infrastructure costs. IoT implementation would allow traffic lights to work in conjunction with a network of other traffic lights, which would also help reduce traffic. IoT could also be used to identify emergency vehicles and have the